Welcome to STEM Lab, where we discuss preparing students for success in a rapidly changing world. And here's your host, Michael Newsome.
Happy to have you here with us today on STEM Lab. Today I have a fantastic interview to share with you. I talked with Joseph Pelfrey. Joseph is the Deputy Director of the NASA Marshall Space Flight Center. Joseph is someone who runs a program with 7,000 people and a $5 billion budget. He's also an alum of the South Carolina Governor's School for Science and Mathematics. There were so many things that I could ask him about. So I talked to him about what it's like to work at NASA. I asked him what it is like to run complex and very complicated projects and organizations. And I also wanted to find out how STEM impacted him and then what we should be teaching kids today. Let's get right to that interview. Joseph, we're glad to have you here today and glad you could spend some time with us.
Thanks for having me on the podcast. This is an honor and a great opportunity.
Now, this is a STEM education podcast, but I've got to ask you some questions about NASA first. You have such an exciting position and career. I was looking at some of your LinkedIn posts and noticed that you mentioned that you were part of the Artemis Generation. Elaborate on that a little bit. Tell us what it means to you and how it's shaping NASA's current vision.
So last year, November of 22, we launched Artemis 1, which was our first mission. It was an uncrewed test flight of the Space Launch System and the Orion crew capsule. And this system is what we will use to return humans to the moon for the first time in over 50 years. And so as we look back in our history, we had the Apollo generation that sent humans to the moon for the first time. We had we call the shuttle generation when we were flying the space shuttle in low Earth orbit and then assembling the International Space Station. And now we have the Artemis generation. And we look at the students that are in schools today are likely going to be the next astronauts that may walk on the surface of Mars, hopefully. And so when we think about Artemis, it leads us to first to return humans to the moon and then establish a sustainable presence on the moon, and then test out the technologies and things we need to allow us to move on towards Mars. So it really is a generational endeavor to really accomplish that goal of putting humans on Mars. And so that's how we talk about the Artemis generation.
Yeah, just this morning, I had one of our computer science teachers come in, Taylor Belcher, and he mentioned just that. He goes, I'm so afraid that I'm not going to be able to live to see us get to Mars. And so we started talking about this current generation being born right now. And it's amazing how important those things are to everyone. You know, that I just had that conversation completely independent of this podcast just this morning.
Absolutely. I mean, this has been a goal of the country for many, many years. You can I have pictures on our walls here of sketches that Werner von Braun made of a Mars mission and what that would look like in the 60s. So even at the start of NASA, there was this long-term goal of landing humans on Mars. And we it's been a goal that we haven't been able to achieve for a number of different reasons, some budget related, some related to administration priorities, but also some technology challenges that we had to accomplish and we're still having to accomplish and solve to be able to make that happen. It is a very audacious mission to put humans on the surface of Mars. And so this step approach that we're taking now with the Artemis campaign is to use the moon and the lunar surface, not just to land and put flags and footprints, as we say, but to really establish a sustainable presence there that will allow us to not only study and do science and research in places on the moon that we didn't do during Apollo, but also to practice and use those technologies and techniques that we are going to need to do that long duration mission to Mars. And so you can get home from Mars or from the moon, in a couple of days with our current technology. You're looking at 8 to 12 months to get home from Mars if there's a problem, right? And so we want to really wring out the technologies and our processes and the things we need a little closer to home so we can be sure that we're not introducing more risk than we need to for our astronaut explorers.
Well, let me ask you a little bit more of a personal career question. If you look back over the last year or so, what are you most proud of accomplishing as deputy director?
Clearly, the Artemis 1 launch was a huge moment, right? Because our teams, we started work on the Space Launch System rocket in 2010 in the early concept development formulation. So 13 years worth of work and dedication from our teams that started from a concept on paper to we have hardware on the launch pad. To see that entire life cycle come to fruition with a near flawless launch and performance of those vehicles, I mean that's a lifetime goal, right? That's a once in a lifetime kind of milestone for a lot of our folks because it does take a long time to develop some of these systems. We have people who had never seen that entire life cycle of a program or project before, and so that was just a tremendous milestone to really see all of that hard work come to fruition. I worked on SLS early in the program, and then moved to different roles, and so to come back to it and be in the room when we had the final flight readiness go poll for launching. Knowing that we were starting this new generation, this new mission, this new campaign, being on the front of that was definitely a highlight, especially after coming through the pandemic. And that's one thing that it's easy to forget that the last couple of years as we were doing some of the most critical hardware builds and testing and integration of that launch vehicle and that system was during the pandemic while we were trying to take care of our people and deal with everything that was going on in the world. But the team stayed mission focused and we had a mission to accomplish. And that's what we rallied around while ensuring that we were taking care of our people. So those things really make me proud of how our team performed during all that.
Well, let's dig into that a little deeper. You mentioned the SLS, the Space Launch System, and I imagine managing large-scale projects like that is terribly challenging. You got all that sophisticated equipment, you got well-educated expert staff. What are some of the key principles that you use or you apply to effectively manage that sort of process?
We have a lot of institutional knowledge from the years of doing human spaceflight that have shaped, our processes and our approaches to how we make sure that the hardware we're building, the missions we're trying to accomplish are going to achieve the goals and have mission success. And mission success includes accomplishing the goals of the mission, but also taking care of the crew, taking care of the hardware, taking care of the people on the ground, the general public, right? We don't want to do anything that's going to harm any of those entities as we go forward. And so we talk about mission success a lot. And so we have pretty thorough processes that were developed from hard lessons, right? If you go all the way back to Apollo 1, the Apollo 1 fire, and the things we learned from that still shape decisions we make today on how we build hardware and how we do operations. The Challenger accident in 1986 on the space shuttle still shapes how we do business today. And then of course, the Columbia accident in 2003. All of those hard lessons where we lost colleagues, they have shaped how we do business and how we manage risk and how we address risk in human spaceflight, because we don't want to repeat those things ever again. And so really standing by those processes and using them with rigor is how we ensure that we can try not to repeat those lessons, right? That they're really lessons learned, not just lessons experienced. And we talk about those challenges. We just recently had an all-day workshop for some of our early career employees who weren't even alive during some of those tragedies, to remind them and to walk through what happened. And it was a hard day because we were revisiting very painful things that happened, but it was important for us to reflect on those things so that this new generation that we have in the workforce now, who didn't experience it in real time, who didn't live it, can still learn from the lessons that came from those events. And so we took a whole day out where we had experts that had been a part of, especially the Columbia disaster, and what all happened in that, and then talk through what it means in terms of making risk-based decisions and how communication plays into that and how leadership plays into that. And so taking what we've learned and the experiences we have is critical, but then also really building a team that you can trust and rely on to go execute. Because with an organization as complex and a mission as complex as we're trying to do and return it to the moon, not a single person is going to be able to understand everything that's happening there, right? So we have to build cohesive teams in a way that we can push decisions down to the lowest level possible and trust our subject matter experts and our technical experts and our leaders to go execute on the objectives that we've laid out. And so it definitely is a team sport. We say that a lot. Spaceflight's a team sport, and it clearly demonstrates that when you think about something like space launch system or human landing systems or habitation systems when we're trying to put humans on another planetary body.
So it sounds like you stay mission driven. You develop really good processes that are informed with this great institutional history that you have over time. But then also there's that human element and that teamwork that's important as well. When you look back at that institutional history, and you mentioned that some of the people that are working today weren't even there when some of those things happened, it reminds me of something I read when I was looking back into your background. And you have spoken before about growing up and your fascination with the Apollo missions and the space shuttle. How did these interests influence your educational path and your career choice?
It was everything. I mean, it became a driver very early in life. I always kind of had an interest in airplanes and flight. I had a family member that had an airplane and knew a couple of people who were pilots, and it kind of grew from there. And when the space shuttle started flying, I was only a couple of years old when we flew the first space shuttle. I think I was probably 4 when the first space shuttle flew. I'll date myself a little bit there, but I really became intrigued with this flying machine. Right, it was a really a very bad airplane, but a great spacecraft, reusable spacecraft, and my dad worked for a TV repair shop, and he would make sure we had a VCR at home where I could record the shuttle launches, and so I would set them up to record way before the days of DVR and streaming, and then I'd get home from school or whenever it was and just study it. I mean, I would watch that launch over and over again, and so when the Challenger accident happened, it was devastating to me because I felt like, well, they didn't get to accomplish their mission, right? Obviously we lost the astronauts, but they were there because they wanted to accomplish a mission, and they didn't get to do that. And I had an uncle that actually worked for NASA at the time here at Marshall Space Flight Center, and he had done some work on he'd done a lot of work on the space shuttle, and was part of helping with some of the analysis on that accident. So to be able to talk to him, and it was kind of that point where I said, hey, this is really something I want to do. And so from that point, at a very early age, I knew I wanted to do something with NASA and space flight. I really want to be an astronaut. Want to be a pilot. And the choices that I made from that point were all kind of centered around figuring out how to make that happen. Now, ultimately, my eyesight was a hindrance to being a pilot, and so I decided to go the engineering route and focus on aerospace engineering, where I went to Auburn, and then came out, and at the time when I was gonna graduate, there weren't a lot of aerospace jobs at the time going on. There were more systems engineering jobs, and And so I took one of those, which turned out to be fortuitous because I really learned that I was a much better big picture thinker than a down and analytical person. And that's really what systems engineering and integration is about, is being able to see the entire system and see how the individual pieces come together and impact each other. And so I had some success there because this is how I was wired to do. So to get back to your question, I think it shaped everything, right? It was, I didn't know exactly how I was going to get there or what role I would serve, but I knew I wanted to be in the spaceflight business in some way. I also did get to go to space camp as a kid, which was kind of cool. And that's here in Huntsville. And so that definitely had an impact and influence as well as I was growing up.
Listening to you reminds me, now this was before the space shuttle, the first space shuttle, but a Scholastic magazine came into my classroom in Wayne County, West Virginia, and it had a cutout of the space shuttle, the proposed space shuttle. And I remember getting into an argument with one of the other boys about who was going to get to take that home after we built it. So it has had such an impact on so many different people. Why do you think NASA's work is so vital for inspiring not just students like you and me, but also the nation as a whole when it comes to STEM fields?
In a lot of ways, you think the inspiration is a byproduct of what we do, but in reality, we talk about inspiration as one of our missions at NASA, right? It is one of our three main goals in our whole Moon to Mars program. Science, inspiration, and national posture. Those are our three whys that we're doing for Moon to Mars. And so it's not just a byproduct. It is something that we focus on as part of what we do, as part of our mission. And I think that's really key, is what it really makes a difference to folks like you and I. Is it is so important because it is a mission in itself. The idea of discovering something new or seeing something or being somewhere that nobody else has ever been before, right, I think is intriguing. If you think about, the frontierism movement, in the early days of our country, as the frontier moved west, it was about discovery. What's out there? What can we use from the land? What are we going to find? And you can extend that same model to our space exploration goals and our scientific goals, where we're trying to understand our universe. We're trying to understand how it was formed, how it operates. That need to explore and observe and understand and learn, I think, is just innate in what we do. And so to have a mission that actually lines all those things up is tremendous. I mean, we have clearly the best mission, I would argue, in the federal government. There are many other important missions that are out there. But in terms of inspiration, that's really a big, it's a big gift that NASA has to be able to do. But there's still work to be done. And it's, I can say this openly. I mean, I still run into people that think NASA shut down after we ended the shuttle program, right? Because, there's a lot of things that can, take people's interest in, and NASA may not be one of them. So we're a pretty small agency relative to the federal government, but I think we have a lot of brand power and a lot of opportunity to inspire the next generation. And we continuously want to improve how we do that, so that there's more folks like you and I that are interested and want to explore and want to be a part of it. And it doesn't have to be engineers or scientists. It can be business professionals or communication majors or lawyers. We have all of those folks that are part of our mission and part of our making our mission happen. And so it's a pretty cool place to be.
Well, let's talk about those teachers a minute. Now, you are an alum of the South Carolina Governor School for Science and Mathematics, and I believe it was 95.
That's right.
And everyone is very proud of you here. Were there any teachers here at the Governor School, or maybe even later at Auburn, who particularly influenced your career path?
You're going to get me in trouble if I start naming teachers, because it's like picking your favorite kid, right? The teachers that are coming to mind are ones that impacted me as a person, right? And impacted me as a student and and what I would later become as a professional. I think that's where I would focus on in terms of the teachers that challenged me to stretch me more than maybe I was stretching myself, the teachers that believed in me in a way that they saw something that I had a capacity to be successful in, if I was willing to put in the hard work to go do that. And the teachers that took time to listen to these crazy dreams and goals that, a high schooler may have, that those are the folks that come to mind with that question in terms of that really had the biggest impact on me. And it was clear all of my teachers at government school had some impact. They left some fingerprint on me to do that. I think I'll just share one example. And one of my favorite classes was actually was Dr. Bill's vertebrate biology class. And it was probably because we got to do some cool field trips. We got off campus a little bit. Dr. Bill had a way of teaching that was, I'll say, relatable and down to earth, right? It was, but he was probably the first one in government school that gave me a bad grade, and kind of woke me up a little bit that, hey, the government school is not your normal high school. You're going to have to put in the work to be successful. And he that first quarter when I got that low grade, it was a wake up call that says, okay, I'm not going to breeze through this anymore. I've got to put the work in to be successful. And he helped me through that, right? He didn't just leave me hanging. But I had to make the commitment. I had to make the commitment and take the initiative to go do that. And so I always appreciated that, probably more now than at the time. But I always appreciate that looking back in terms of instilling that ethic, that work ethic of trying to be excellent at what you're doing, understanding you may fail, but you got to pick back up and go after it again. I think was a one good example of a big impact for me.
That's interesting. I hear that over and over again, that some of the teachers that make the biggest difference were also the toughest teachers, but they were the ones that cared. I'm kind of curious, with your background in engineering and your career experience, how do you feel about theory versus practical application in the classroom? Teachers always talk about this. How much should we involve kids in projects versus getting them to understand the theory? You only have so much time. You would love to be able to do both. Do you have a take on that?
I do. And I, this is Joe's opinion. I'm not an educator, but what I see in hiring, I've hired a lot of people over the last 23 years at NASA. And especially today with the availability of information, the new students and the new early career folks that we hire have access to so much information that they can readily tap into. Seems to lend itself that the teaching of the theories may not be as important, because the theories are there that people can go learn or they can go research on their own. What I see they don't come out prepared for is how to work in teams, how to manage their time, how to interact and communicate in such a way that you can tell your story to the audience that you need to tell it to. And that could be anywhere from a deep technical conversation to upper management where you're trying to get approval for a new budget or a new program or whatever. And so those things are learned in the applications, right? In the projects and the hands-on things where you have to kind of work your way through dealing with your teammates and conflicting styles of the individuals, the failures and successes that you have in working through those projects. All those things to me are part of that application piece, and it's really what you see the most when you get into the job environment, right? The environment of what we're trying to do. You see where that where it may be strong or where it may not be strong, and what they do. So there's definitely room for both. I mean, but clearly, I couldn't go search Google on a theory of something, when I was coming through government school. But now, I mean, it's on your cell phone. You can pull up a theory of something and you can study it. You could probably even find a YouTube video of somebody teaching it to you that you spend 2 hours on, and now you go apply it. To me, it's going to be, it sets you back if you come into the workplace and you haven't done the application side and haven't done the teamwork side of the work. You can learn it for sure. It's going to be trial by fire and OGT to some extent. But that's just my experience and what I've seen in hiring new folks to come into NASA.
What do you think are some of the most critical skills or areas of knowledge that STEM educators should be teaching the kids today, particularly those interested in advanced engineering or space exploration, aerospace?
When we talk about capabilities and skills that we need to go accomplish what we're doing, there clearly is room and a need for deep technical expertise in a single area. We have to have technical experts in material science or in thermodynamics or structural mechanics or, turbo machinery for a propulsion system. But we don't need as many of those as we need folks who are able to take multiple disciplines and put them together to a system, because ultimately what we're doing is building systems. And so that's why the systems engineering, I think, discipline has grown so much over the last, 25, 35 years, was because the industries and the government agencies saw the importance of how these increasingly complex systems interact with each other and understanding how those are going to come together and trying to find clearly the places where they're not going to work well or where you may have issues in bringing those together. And so we focus on the multidisciplinary engineer more now, in addition to having those deep subject matter expertise in what we do. I think the emergence of artificial intelligence and machine learning is something that clearly we're talking about. I believe that's an area where honestly NASA is probably not as advanced as maybe some other areas, and where we know that we're doing a lot to play catch up and try to figure out how we infuse that technology and capability into what we're doing. There's a lot of very interesting applications, especially when you think about going to Mars, where there's maybe a 15 to 20 minute communication delay. You don't want your systems to rely on ground commanding from Earth as much for critical things, or as little as possible, when you have that long of a delay to get that command to whatever system you're trying to operate. And so how can we use AI and ML to do predictive commanding, in situ on the surface of Mars without having ground interaction, for example? How can we design the system so that they're smart enough to know I'm about to break, therefore I need to send command X, Y, and Z to prevent that break from happening and to prevent something bad, on the surface, that it would take 15 to 20 minutes for the folks back on Earth to figure out what happened. So I think that's really a huge emerging skill that we need to start focus on in the schools today and tap into this generation that grew up with computers and devices and coding, and they're going to adapt a lot faster than I will, for sure, in that area. And I think that's one that we see a huge need for, emerging, and not just in the software coding piece of that, but the application of what you can use those tools for in so many different areas.
Yeah, I had that conversation with the president of the governor's school just this morning about that interaction between the human and the artificial intelligence. That's where the skill set really needs to be developed. And so teachers need to get that professional development in developing that. It's it's something that's going to be very important for the success of the students and for the country. Is there, this is a little bit different question, but what kind of resources or programs at NASA that teachers might not be aware of would you like to recommend?
NASA has a very robust STEM engagement program, including things we do for students and then things we do for teachers. So we have curricula that's been developed for a number of different areas related to space flight in science and discovery that we make available to teachers. And most of the things can be accessed, at least to find the right points of contact through the NASA website. The Space Grant Consortium is another resource. So all 50 states have a Space Grant Consortium POC. South Carolina, there's a professor at the College of Charleston who is the South Carolina Space Grant, authority. And they get each state gets some amount of money from NASA to really support the STEM activities and helping schools across the state do that and engage. The competitions that NASA runs is really a great tool to engage both teachers and students to get some of that application experience we're talking about. We host two big ones here that I enjoy talking about: the Student Launch Initiative, where teams have to build a rocket and they have to meet certain objectives that we set out each year for that rocket launch. They get to build, design, do testing, and then they come here for a long weekend, and then we launch them just north of town. Most of the time they go about a mile up and they have some objective they have to accomplish. So that's a great example of taking their engineering experience and teamwork experience and applying those things they've learned in real world situations that we give them. We also have the Human Exploration Rover Challenge, which is very similar, where teams have to build a self-powered or human-powered rover. And we set up a course, and they have to navigate this course like you would on the surface of the moon or surface of Mars. And so two examples of where NASA is trying to really not only inspire, but also give students and the teachers and advisors that work with them a chance to see and work through real mission scenarios that we're dealing with, but also to really get that experience and that all those things we talked about in terms of application. So a lot of resources available. And you can start on the NASA website to kind of get access to those. And then again, those STEM points of contact are our space grant folks that are out there to help as well.
Well, Joseph, I've really enjoyed the conversation. Let me ask you, is there anything else you'd like to say out there to kids who might be interested in careers in space exploration?
Yeah, thank you. And thanks for having me on. This has been really great. Enjoyed talking to you. I'll say that my time at the Governor School was a huge impact on me in my career and my personal life. As some folks may know, I met my future wife at the Governor School. She is a NASA employee as well, and so we get to go on this journey together, which is pretty awesome. You can look at me as an example of a small town kid who had people who supported me and believed in me, but also instilled in me the importance to believe in myself and to work hard and take the initiative to really achieve anything you want to achieve. I can tell you, I never would have imagined from where I started, humble beginnings, to being able to lead one of the largest NASA centers and 7,000 people and a $5 billion budget to return humans to the moon, to advance scientific understanding and discovery, and to develop technologies that we're going to use for the future. I never would have imagined that my path would have taken me here. And so I just encourage the students that are out there to dream big, be willing to work hard, and take advantage of the people that are willing to support you and pour into you, because with those things you can reach the stars.
Well, Joseph, thank you so much.
Thank you for having me.
It was really nice talking with Joseph Pelfrey. He's so humble and easy to talk to. One of the things that stands out to me in that whole interview is when he was talking about teachers, and those teachers that are able to challenge students, that give them something to really work on, but then help them succeed. That can make such a difference in someone's life. Hope to keep bringing you more and more interviews like this. Be sure and contact me. You can look at my LinkedIn. You can look on the Govy Media website. And until next time, Keep learning and growing.
You have been listening to STEM Lab, produced in the studios of the South Carolina Governor's School for Science and Mathematics.